No problem. So, good morning, class. Our topic for today is about standard vapor compression cycle. Now, standard vapor compression cycle. First, I would like to discuss why is this called a vapor compression and what are the different types of refrigeration. So, when we talk about refrigeration, so when we talk about refrigeration, it's the process of maintaining and controlling the temperature or humidity and other properties of the surroundings, no, and it should be cooler or colder, yeah, colder than the original surroundings. It should be cooler than the original surroundings. And how is this happening? This is happening due to the so-called heat transfer or thermodynamics. So let me just. So the process involved here is the so-called thermodynamics, and of course, during thermodynamics, uh, this phenomenon is happening: heat transfer. So thermodynamics comes from the word thermo, means heat, and dynamics means what?
Movement.
Movement. No?
Movement.
Yeah. So if you want to understand refrigeration or air conditioning, you should be able first to master or understand thermodynamics. And thermodynamics is the movement of heat from one place to another, from one point to another, maybe by natural means or mechanical means. When I say uh, heat movement or heat transfer, for example, in your house, let me use this now. For example, in your house, how is heat transferred? Is being transferred here because we have this sun, right? And the sun has the sun rays, the sun rays. So that transfer of heat, the mode is so-called radiation, because the sun is radiating its heat energy. Yeah, and the heat of the sun is also being transferred through air, through fluid. So we call that transfer heat transfer mode as convection. And then when it goes to the solid, like the roof, yeah, then in the roof there are some, some materials there, like the wood and the nail and others. So when it is more about solid, yeah, or contact, so the heat transfer is conduction. Yeah. So when it involves fluid like water or air, convection. Conduction is more of direct contact into solids, and radiation is another thing. Yeah, it's more of another element. It's the formula here is much different. Most of the time, we are only concentrating here in the convection and conduction because it involves solids and the liquids, like water and air and others that we are coming we come in contact with. We always live with them in our everyday lives. Yeah. So the concept of thermodynamics is very clear. It is the transfer of heat. When heat is transferred, when you remove heat, it will become cold, right? Then when the heat transferred to cold matter or body or object, cooling can happen, because the absence of heat is coldness. No? So the term heat and cold is kind of abstract here. Yeah. So heat and cold is abstract, meaning um, we should be very clear. It's because it's a concept. We should be very clear. Our mind should be very clear on these two concepts. with the backing or with the support of scientific explanation. For example, we normally interpret that boiling is associated to hot, correct? How
Yes.
much temperature is needed? I mean, when you boil a water, how what is the temperature that the water starts to boil?
100 degree Celsius.
100 degree centigrade,
Celsius. Yes.
centigrade or Celsius. So that means when you heat up water from your oven or kettle, it will become it will boil. No, it will start to boil at 100 degrees centigrade. So that's why in our experience, in our life experience, we associate boiling into hot, no, hotness. Then after the water boils, yeah, it can no longer stand or stay in boiling. There will be a change in form, right? So the change in phase will happen, and it's uh, meaning the 100 degree centigrade water will become what? 100 degree centigrade
Steam.
steam or vapor. No? So what
Yeah.
happens here is there's no change in temperature, right? Look at this temperature, 100. But the only change that happened is the change in state, yung anyo, yung form. Anong anyo? Dating tubig, ngayon naging steam or vapor. And that is what we called in engineering or thermodynamics as what? Anong
Heat.
tawag natin doon?
Latent heat. Phase.
Latent
Phase.
heat.
Ayun.
Anong klaseng latent heat? So when there's no change
Okay.
in temperature, but there's no change, but there's a change in form, we call that latent heat. But what kind of latent heat? Let me use another color. Latent or latent heat of
Fuel. Ano?
Fusion.
va-
The
Vapor.
vaporization.
vaporization. Yeah. So that is the contrast of another latent heat, right? If I may review you, last time we are solving the ice refrigeration. There is this scenario wherein you have an ice, right? An ice, example, a cube of ice, yeah, cube of ice. Then this ice, for example, is 0 degree centigrade, yeah. Then this ice will turn into what? Water,
Water.
right? If you increase, uh, I mean, if
Temperature.
it's subjected to a certain surroundings. Now, when it reaches 0 degree centigrade, before it goes to the temperatures above freezing, yeah, because this is freezing, right? Below freezing is here, going to the left, below freezing, yeah. Then going to the right is above freezing. So we are expecting that the temperature will go up. But before the temperature goes up, it will go into a certain process, a transition wherein they have the same temperature, which is 0 degree centigrade and 0 degree centigrade also. But this one is ice, which is solid, and this one is what? Water, which is what form is
Liquid.
this? Liquid. You see, there is no change in temperature, but there is a change in form or state. Yeah, so that is what we call latent. By the way, what is latent or latent? The literal meaning of latent is concealed, nakatago, no? As I told you, when you study engineering, you should study English, no? Because the medium of communication used in engineering, especially in the Philippines, no, and other countries, is in English. But if you go to Germany or Japan or France, of course they're going to use their own language. But since we are using English in the Philippines as one of the official languages, aside from Filipino or Tagalog, we should understand the terminologies used in engineering. Yeah. So latent means concealed or hidden. Hidden, right? Nakatago. Bakit nakatago? Kasi hindi mo makita yung pagbabago sa temperature. Can you measure the heat in latent? Yes or no? Is it measurable, the heat? Is there a heat transfer in latent?
Wala po.
Wala, kasi no, delta T is zero, no? Delta T or heat transfer will only happen if there's a change or delta change. Delta is change, right? If there's a change in temperature. But since 0 degrees centigrade ice and 0 degrees water, there's no change. So you cannot measure the heat. Now, if you put a temperature recording machine, meaning thermometer, you cannot see the change in temperature because what is happening is there's no change in temperature, but something is happening, something change is happening, and that is change in phase or form or state, right? So that is why it is called latent or hidden. Now, this latent is not of vaporization because there's no vaporization happening there. This is called latent heat of fusion, no? That's why we call this as LF, latent heat of fusion, right? So why we are discussing that, because we are discussing the concept of heat, and heat is energy and hotness and coldness is just a concept that should be backed up by scientific explanation. I want to emphasize that boiling, we associate boiling into hotness. Now, but that is not always the case. In water, it is true because the water will boil when it reaches 100 degrees centigrade, no? Not less, not more than that. But the refrigerant, now the refrigerant, we are going to take this up when we have time. But right now, I'm emphasizing more on the topics that need calculation, because board exam is more on the calculation. Refrigerant is the working fluid in the refrigeration system. When we talk about refrigerant, we are talking about R12, R22, R134A, R413, like that. And ammonia, yeah, this NH3. When you talk about ammonia, this is 700 series, yeah, 707, 717. So these are the refrigerants, and we are not going to talk about this now. What I'm saying is the property of refrigerant, even in atmospheric, like what is atmospheric? Maybe 25 degrees centigrade, it will boil, no? Or even at lower, maybe 20, maybe like 0, maybe negative, yeah? Even at very low temperature, it will boil. If you are getting what I'm trying to point out. Because before we are saying water, it will boil at 100 degrees centigrade. That is true to water, but we are not talking about water now. We are talking about another fluid, which is refrigerant. Even at lower temperature, like -5 or 1 or 2 or 3 or less than that, the refrigerant will boil. So we could not say that all the things that are boiling is hot, right? This is hot, but this is cold. Yeah, negative is cold, or 0, 18, 15, 14. Yeah, lower than 20, it becomes cold, or negative. Yeah, so negative temperature is cold, but it's boiling, right? So that is what I'm trying to say, right? So what my point is we have to have a clear understanding of refrigeration, and that is maintaining and controlling of a body or a place um, which should be colder, which means lower in lower temperature than the original surroundings. For example, the room. yeah, the room. You have to condition the room. Now it should be colder, and also the meat, yeah, the meat in the refrigerator, the water in the refrigeration. When I put water inside the refrigerator, it's not yet cold, right? But it becomes cold because we are refrigerating it, right? The ice cream, the meat, and so on. So the concept of refrigeration is clear now. So it is cooling the body or the place, yeah, colder, oh, in a temperature lower than the original, yeah. So there are many kinds of refrigeration, if I may put it here, yeah? So last time, I mean last week, last few weeks, we are talking about ice refrigeration, yeah. And this is it. And then the other is um, uh, the other is the one that we're going to discuss later on is at the end of this subject, yeah, absorption refrigeration. There is this so-called air cycle refrigeration, right? And this steam jet, right? Steam jet, okay. And there is this science of very cold temperature, yeah, like so called cryogenics. Now they are using it in things, and also in materials, and also the human body. If you want to right now, the body, especially in COVID area, COVID period, you are trying to facilitate or process everything in a faster way. That's why you are using cremation. What is cremation? What is cremation, class? Cremation is like burning, yeah, burning the body. Then the body will become ash. Cryogenics is used also in that process. The dead people are being refrigerated in a very very low temperature until they become like brittle. Madupok na sila, no? Malutong na. So isang pitik mo lang, ano na, yellow na, 'di ba? Yung parang para kang nasa Antarctica, no? Pwedeng mabasag lang. So there are many research in refrigeration, and these are the type of refrigeration. Uh, the others we are just going to discuss the concept, but the one that we are going to discuss most is the ice refrigeration, and this one that is based on the vapor compression cycle, right? This is the one that we are going to focus more on. Yeah, let me erase everything. Yeah, that's why we are free. So now we go back to the refrigeration cycle using vapor compression cycle. And why is it called vapor compression cycle? From the term itself, yeah. What we are doing with the vapor? We are compressing. And where is that happening? So let me have this. Oh, what is this? Cold air. Oh, this one is what? The one on the left is what? What is this? Do you know? What equipment is this? Because we are going to study the equipment of refrigeration system, right? This evaporator is in the low side, low pressure, because you can divide the system into two, yeah. What about high pressure? Where is high pressure happening, class? Hmm? This is happening in the condenser side, okay. So now the compressor is the heart, means the center of the process. What the compressor does is compressing the refrigerant, right? So the refrigerant is coming, for example, here, if it's in the evaporator. Let me have this. There's another here, TXV or XV, yeah. So this one is expansion valve, or the so-called thermo expansion valve. Yeah. So others are using expansion valve, the others are using thermo expansion valve, but basically this is just the same thing. So from the condenser, so it is fluid, it goes to thermo expansion valve, right? And then the thermo expansion valve is still in fluid form, right? But it should be in a lower temperature. So if you can guess, if you can infer what's happening in thermal expansion bulb, let me say that this thermal expansion bulb, I will explain. By the way, I will explain the refrigeration in a very uh, simple way, like refrigeration for non-engineers, right? So I think it's better that way before we go to the more highly technical way of explaining. So here is the expansion valve, and all it does, what it does is pressure reducer, meaning it is reducing pressure. Why? Because from the condenser, you see, from the condenser, from the condenser, the pressure of the refrigerant is high. That's why it is high side. No, high pressure means high side because there are two sides. So evaporator is low side part of the system. So from from the when it exits to the from the condenser is still high. The pressure, I sorry, the pressure is still high, right? So here the pressure is still high. We need to lower down the pressure, and the function or the device that does that is the pressure reducer. So when it goes to the evaporator, it is only lower pressure. When the pressure is lower, the temperature is also lower, yeah, because of the ideal gas law. So we need to have a low pressure refrigerant, low pressure refrigerant in the evaporator. Okay, now what's happening in the evaporator? The evaporator inside the coil is of course the refrigerant, right? So refrigerant, what form? It is still semi mixture of fluid. It's a mixture of fluid here in the evaporator, no? Some part of vapor and some part of fluid. Yeah. Now, how it becomes how it become, how will it become vapor? Yeah, because it is evaporator, right? Means it is evaporating. Yeah, it should evaporates the fluid inside, and the purpose of evaporator is it absorbs heat, Q in, or QA. What is QA? Heat added, no? So heat is absorbed or heat is added by virtue of the process, so that when you add heat, no, when there's when it absorbs heat, the refrigerant will uh, vaporize, yeah, or boil. So now the question is, where is the heat coming from? Heat, the source. So what are the sources of heat? No, for example, if you are inside the refrigerator, those items that are inside the refrigerator are the contributors of the heat, like the meat, the water, the vegetables, yeah, veggies, and all the other things that you put inside the refrigerator. What if you don't put something in the inside the refrigerator? Does the refrigerator still heat up? Still cool? Yes, because inside the refrigerator there's an air, right? There's an air. When you close the refrigerator, there's an air trap. There's a wall, right? The materials of the wall, yeah, the materials of the wall, and so on. The iron, everything, the plastic there, yeah, they have thermal conductivity. Yeah, K is the symbol for thermal conductivity. So each material in everyday life in the world has the capacity to have heat, and that is thermal, or to conduct heat. That is thermal conductivity. So even your refrigerator has no stuff inside in it, the refrigerator will still cool, and the evaporator, the chamber will still have these crispy eyes and everything, right? So in the process, when heat is absorbed, the refrigerant will be heated up and it will become vaporized. So when the refrigerant is vaporized, yeah, it will go to the compressor. Why? Because compressor only absorbs vapor. I'll repeat. The compressor only absorbs fluid in gaseous form. You cannot you cannot put water or liquid in the compressor because it will explode. Yeah, because by theory, fluids or liquids are incompressible. So when you compress the fluid, no, it will explode. But there's another device that can deliver a fluid. Yeah, I mean, used for delivering fluid. That is pump. Yeah, so the pump can be used for compressing or transferring the fluid in a pressurized form. But we are not talking about pump. Now we are having the compressor. That's why it should be in gaseous form. Yeah, and as I said, low side, low pressure because of the thermal expansion valve. From the thermal expansion valve, it reduces down the pressure. So how do we call the evaporator? How in a layman's term, so it is called heat and other. Yeah, so we add heat. Yeah, heat other, we add heat, and then compressor is what? Of course, pressure. Yeah, pressure other or increase. Yeah, we increase pressure increase or pressure addition other. We add the pressure here. Well, what about the condenser? What is happening? What happens to heat? Q reduce, no? Not reduce, what do you call it? Heat reject. We throw, we throw away the heat. We QR means Q reject. We reject the heat in the atmosphere. When you reject the heat, when you remove the heat, certainly the body will become cold. So the refrigerant, when you remove the heat from the refrigerant, it will become fluid. It will become condensate. That's the product of condenser. Yeah, somewhere here it will become condensate, right? Or fluid form. Why? Because the heat was rejected to the atmosphere because of the heat exchange. Why heat exchanger? So these two, let me emphasize, there are two heat exchanger. This one and this one. Yeah. So heat exchanger means they are exchanging heat. Therefore, the minimum medium is two. Now there should be two medium. So one is the refrigerant and the other is the air. So the air is here. The air is with the fan. Yeah, normally when you study refrigeration, of course this is the basic, but in actuality there's a fan. Yeah, there's a fan blowing. So there's a fan here, blower, like a blower blowing here. Yeah. So it is absorbing heat, but it's blowing. So when it blows, yeah, coming from the evaporator, the air is now cold. Yeah, the air is now cold, yeah, because of the heat exchange, right? So the air is now cold when it blows because there's a ducting, and it is the one trying to cool the air in the or the surroundings in the refrigeration, in the air conditioning or in the refrigerator. It is giving off cold. Yeah, because when you add heat, then cold is being thrown out. Here, when you reject heat, right? When you reject heat here, The absence of heat will turn the refrigerant to become cold, right? I mean, lower the temperature and the pressure, but it's still hot. No, it's still higher, but lower than the compressor, right? So because here the when heat is rejected, meaning the body is cooling down, and when you reject heat, the absence of heat will transform your liquid refrigerant, no, liquid refrigerant to I will the vapor, right? Sorry, the gaseous refrigerant vapor refrigerant, it will become liquid refrigerant. Now that's the product of the condenser, which is the condensate. So basically, that is the the process of standard vapor compression. I guess you already mastered that because the first meeting, that is what I have discussed to you. No, so this one, let me pull out another. Uh, yeah. So here, what I'm going to discuss right now is the tool in studying the refrigeration or air conditioning. There is the diagram, and that is called the pH. Pardon me for my handwriting because I'm not used to digital pad. Now I'm still studying now. So this is a pH. It should be straight, right? It should be straight. Uh, I guess the pH is this one. Okay. Um, the form is like this. So when you see a diagram like this, what do you call this, dome, it's like it's called the pH. And by the way, P stands for pressure and H is for enthalpy. Let me pull out. I think I have another software from Microsoft, the Microsoft whiteboard. Let me try. I think it's better to put here. Yeah. Oh, it's still installing. Okay. While while the whiteboard is installing, let me go back to this. So here is the so-called pH. Yeah. So normally the pH is like this. It's like a dome. Then we discuss what are the parts of the pH diagram. So P stands for pressure, and H is what? What is H, class? H is enthalpy, right? So H is enthalpy. So these are the properties of thermodynamics now, whether in air, whether in fluid, whether in gas or other form. So that is enthalpy. Now we can divide the this curve into two, right? Uh, like half. Yeah. So let me use another another color. Let me discuss first some relation. Yeah. What if, class, what if the pressure and enthalpy is directly proportional? Meaning, when I add pressure, the enthalpy is increasing. So that relation is the so-called linear, right? Or the so-called proportional. Yeah, there's a correlation between the two. So here, if there's an increase in pressure, there's an increase in enthalpy. Whatever enthalpy, there's a pressure. Whatever pressure, yeah, there is an enthalpy. So we can get a direct relation, and that is the line. You know, what if I add, if the what if the enthalpy is increasing and the pressure is going down now, so that is inversely proportional. Yeah, so here, inversely proportional. Okay, just to review you with the relation in a graph. Yeah, meaning the pressure is high here, right? And the enthalpy is low. Here, the pressure is becoming low, right? I have a low pressure, but my enthalpy is high. That means as the pressure decreases, the enthalpy is increasing. Yeah. So how do we relate here? In this case, the pressure and enthalpy is somehow having a linear relationship. When the enthalpy is increasing, the pressure is also increasing. But here, there's a non-linear. Yeah, from here to here, there's a nonlinear. What is nonlinear? Nonlinear means it is no longer one is to one, no? Because before when we increase the enthalpy, it's increasing the pressure. But now the enthalpy is the pressure is, look at this, yeah, the pressure is trying to become like a constant, yeah. Somewhere here is the same, and then the pressure is starting to decrease. Once the pressure is starting to decrease, what is happening to the enthalpy? It is still increasing, right? So here the pressure is going down. Look at this. The pressure here is down, but the enthalpy is still high, or here, yeah. So the pressure is here, but the enthalpy is here. Okay? So far from the linear. Now, if it's linear, so it should be straight. Now, as the enthalpy goes up, the pressure also goes up. Now, so I think it's a good way to understand the the pressure enthalpy. Let me go to the part of the pressure enthalpy. Yeah. So again, I'm writing this, and when you plot all the temperature and the pressure and the temperature, you will have this. Now that's why you're asking. Maybe you're asking why is this like a dome? Yeah. So this is the plot of the properties. Properties. Yeah. So here we can divide into half left, and half right. So the curve is the so-called saturation line. Saturation line. It is a line that has saturated properties like saturation temperature, saturation pressure. So if you have a saturation line on the right, you have also saturation line in on the left, saturation line. The only difference of the two is this. On the left, yeah, on the left, oh, let me have this. Yeah, on the left, it is liquid, saturation. The form is liquid, no, fluid, basa, wet, 100% wet. Okay, so liquid, so it is termed as F. Yeah, for example, if you get an enthalpy here, for example, I get an enthalpy here. Now I project it downward, so I get an enthalpy here. So what is this enthalpy? HF, enthalpy fluid, saturated fluid. No? So what about here? On the half right, this is a saturation line called vapor, yeah, saturated vapor. So this one is H, yeah, HG, or the others maybe capital HG. What is G? Gas, gaseous uh, form or vapor, right? So again, this is vapor, this is fluid. So this one, if you get the enthalpy HF, this one is HG. So this is 100% fluid, and this is 100% vapor. That's why it is called saturated. Na saturated. But when you increase the temperature, by the way, the temperature, let me use the another color. By the way, the temperature line is this, right? So this line, yeah. So this line, yeah, like this, yeah, yeah. The I mean the direction of temperature, yeah. So yeah, that yeah. So this line are the temperature temperature curve or lines. What about the pressure? As you can see, the pressure is here on the vertical, but you read this as horizontal. You know, P, for example, here, P, 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 P. Yeah, P. Constant pressure. Why constant? Because it's straight. Yeah. So meaning whatever enthalpy you have, yeah, whatever enthalpy is there, you are just having a same pressure. Yeah. So this one is also the temperature. Okay. So we learn about the temperature. We learn about the pressure. They are where they are located, and now we are going to discuss some properties, which is the so-called X, not the X quality. So in steam power plant or refrigeration, it is used, no. So another term for quality is the fraction, the vapor fraction or steam, na uh, fraction. Okay, what is this X? So where do we see the X here in between? So here in between we have the quality. What quality are we talking about? Quality of dryness. Yeah, dryness. Yung pagkatuyo. So that's why it is called dryness fraction. The dryness fraction, meaning fraction, like percentage, yeah, half, not whole, yeah. Oh, what is half? Point 0.5, fraction, one half, right? Like that, yeah. So dryness fraction. So there is a fraction or quality of dryness in between the fluid and the gas. That's why there's a so-called X, meaning this is 100% fluid, this is 100% vapor. In between, there is this fraction, meaning uh, if half is 50%, maybe 40, 30, 10, this is 9, 80, 90, 95, 98. Yeah, so if you are near the saturated vapor line, maybe you are 99 or 98, right? 98% or 99. When you reach this line, let me mark this off. When you meet this line of saturation, what is this? What quality is this? 100% vapor. This one is 100% fluid, no, 100% F. What is that? Ano yung class?
Wala fluid.
Ah, so sa left class ay fluid, sa right ay gas. So in between them, bagong maging dry, purely dry ang refrigerant, dumadaan muna siya sa transition. Ibig sabihin meron siyang dryness fraction. Hindi siya kompleto like 95, 98, no? 97, ano? Kasi galing siya sa fluid. Ngayon, pag lampas na siya ng saturated, no, tinan mo yung curve na dinodrawing ko, no? Ganyan, ganyan. Merong curve na ganyan, ang tawag diyan ay superheated. What is superheated? Yun yung region above saturation line. Kaya yung compressor, naalala niyo yung compressor, anong ginagawa ng compressor? Ang ginagawa ng compressor ay i-compress ang refrigerant. Pag kino-compress mo yung refrigerant, tataas yung pressure, tataas din yung temperature. So mataas na yung temperature, mataas na yung pressure, no? Pag mataas na yung temperature above the saturation, ang tawag mo doon ay superheat, no? Superheated, no? Pag past tense. Ngayon, meron namang mas mababa sa saturated vapor. Anong tawag doon? Subcooled, no?
Subcool.
Yeah, subcooled. Yeah, subcooled yan kasi mas mababa na. Ito naman mas mataas sa saturation ay superheated, no? Superheat, mas mataas na. Okay? So pag dito nag-boil na, tapos papataasin mo pa, 'di ba? Kasi yung refrigerant, 'di ba, vapor na tapos i-compress pa ng compression ng compressor. Ganito 'yung nangyayari, 'di ba? Nagiging superheat. Ngayon, drawing ko para naintindihan nyo. Yung pinapaliwanag ko kanina na standard vapor compression, mapaplot mo rin. You can also plot here in the pressure enthalpy diagram. So let me use uh, another color. So look at this. Halimbawa, dito yan, no? I-translate ko lang dito, no? Para malinaw tayo bago tayo maghiwa-hiwalay, halimbawa ngayong araw na to, no? So, eto, kung meron dito, no? Ano ba dito siya, no? Halimbawa, dito ay fluid. Halimbawa, refrigerant ay fluid, di ba? Pag bumili ka ng refrigerant sa mga refrigeration store, mga 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 parts and supplies and materials, magkakaroon ka ng fluid, no? So, dito yon, no? Fluid. Ngayon, pag tiningnan mo dito, yan, no? Etong baba, ito yung ino-occupy ng evaporator. Kasi low pressure, mababa yung pressure. Ngayon, from evaporator, gas yan, gas, 'di ba? Ito gas, no? Ito yung saturation line ng gas, no? Kasi tumama sa curve, no? Pag tumama sa curve, saturation line yon at madali siyang malaman yung mga properties kasi pupunta ka sa refrigeration table na makikita mo agad, no? Kasi mas madaling hanapin yung saturation line ng properties. Ngayon, eto, yung ano na yan is yung compressor, work of compression, no? Compressor yan, nangyayari dyan. So from compressor, ano nangyari? Tumataas yung pressure, di ba? Ayan, no? Tingnan mo yung pressure. Tataas yung pressure. Nasaan na yung pressure? Ayun na, ayun na yung pressure. Di ba? Tataas din yung temperature. Siyempre, ideal gas law eh. Yung temperature tsaka pressure tataas. Ngayon, yung ano naman, yung sa compression, may work of compressor diyan, no? Hindi naman yan mananatili diyan. No, kailangan niyang gawing condensate or fluid ang refrigerant. Sinong gumagawa noon? Kailangang itapon niya yung ang init. Ito ay condenser. So heat rejected. Okay. Sa evaporator, heat added or heat in. Heat in sa evaporator, dito sa condenser, heat out. Okay? So, dahil pareho silang heat exchanger. Etong nasa kanan ay compressor. Ngayon, yung pababa na depende sa process, pwede kang bumaba within the dome, pwede ka rin bumaba dito sa point na to, no? Depende sa problem. Pwede dyan, or pwede ka rin maging subcool, tapos baba ka uli, no? Parang yan. So, ano namang equipment to, class? Yung pang-apat? Ano to? Ay, sorry. Expansion valve. No. Tingnan mo, yung nangyari sa expansion valve. Ano nangyari sa pressure sa expansion valve? Bumababa o tumaas? Ano nangyari sa expansion valve? Bumaba yung kanyang pressure, di ba? Ito, tingnan nyo. From here sa condenser, kasi condenser is high side, no? Q, H, mataas. Ito Q, low, mababa. Heat added sa evaporator, heat rejected sa condenser. Ito naman ay compressor, kaya tumataas ang pressure. Tingnan nyo, kumataas din ang temperature. Ngayon, pag nandito na siya, kailangan pababain na bago pumasok sa evaporator. So, yun ang duty ng expansion valve. No? Expansion valve, papababain niya yan. Okay? Pababain niya yan. Para pagpasok niya sa evaporator, low na, low. Kasi low side nga to, di ba? Low side yung evaporator eh. So, mababa na yung sa evaporator kasi nagiging vapor siya. Yung vapor na mababa, tataas na naman, no? Kasi i-compress siya eh. Tataas na naman yung pressure, tataas na naman yung temperature, at ito naman, iaalis naman yung init, heat rejection, no? Tapos ito naman, papababain na naman yung pressure. Kaya tinatawag nating cycle kasi nagkakaroon ng loop or paulit-ulit, no? Repeat itself, repeat for so many times, several times, over and over again, kaya siya ay cycle, no? Refrigeration cycle. Maliwanag ba, class? Hello?
Opo. Opo.
Maliwanag, no? So, burahin ko lang to, no? Yung ano, para maliwanag daw. So, here, meron tayong sample, no? Dahil maliwanag na yung standard vapor compression cycle. I guess meron tayong sample dito. Ito, medyo mahirap na yan, no? Dapat yung simple lang. Ito, number 5. Yan. Okay, number 5. Okay? So, ito, bibigay ko lang yung given, no? Bago tayo matapos, ibibigay ko lang yung given. and then kayo na ang mag-solve, 'di ba? Ganon, ganon lang ang gagawin, no? So, paano niyo ma-solve to? Tingnan niyo yung mga video, no? Nilagay ko na to sa video sa channel natin. Pwede kayong mag-refer doon. But before ko kayo iwanan, no, mag-check pa tayo ng attendance. So, babanggitin ko lang yung mga given para malinaw sa lahat, okay? So now we are trying to solve problem number 5 in my notes. It says a vapor compression refrigeration. So from the term itself, vapor compression, just what we have discussed a while ago. Vapor compression refrigeration system using ammonia. Anong refrigerant natin? So ang system natin ay
Ammonia.
vapor compression, no? Vapor compression. Hindi yan air refrigeration, hindi steam refrigeration. Now, anong refrigerant natin? Anong refrigerant?
Ammonia.
Ammonia or NH3. Yan, sa malalaki ginagamit yan. Working substance means refrigerant required to provide 30 tons of refrigeration. So merong term na tons of refrigeration. Makikita niyo yan, no? Tons of refrigeration is 30 tons. Yung capacity, no? Pag sinabing tons of refrigeration, you are talking of capacity, no? Parang kilowatt or horsepower. Now, by the way, ang conversion, no? There is 3.516. Ilan yon? Kilowatt per ton of refrigeration. Okay? Now, is required to provide 30 tons of refrigeration at 16 degrees centigrade. No, tingnan mo, may temperature tayo dito na ng refrigeration is 10-16 degrees centigrade. To accomplish this, no, kasi mababa na to, di ba, sa refrigeration, no? Uh, ibababa niya sa 16. To accomplish this, the ammonia operated between pressure limits of 144 and 1,400. Tingnan nyo, meron agad na binigay na pressure, di ba? So yan. So ipa-plot mo yan sa pressure, dalawa agad. Ano yung yan? Meron kang low pressure. Saan nangyayari pala yung low pressure class? Saan nangyayari? Evaporator o condenser? Saan nangyayari yung yung low pressure? Sa evaporator.
Expansion.
Saan nangyayari yung high pressure? Sa side ng
Condenser.
condenser. Bakit? Kasi ano na 'di ba, dadaan siya sa compressor eh, 'di ba? Pag gumanto, 'di ba? Pag gumanyan, halimbawa, pag gumanyan, ito yung compressor mo, 'di ba? Compressor mo. So pagdating niya sa condenser, ito yung condenser 'to, 'di ba? Condenser line. Pagdating niya sa condenser na, mataas na yung pressure, 'di ba? Ito evaporator, mababa, 'di ba? Low pressure, high pressure. Bakit naging mataas? Pinataas ng compressor. Okay? Yun lang yun. So, pag sinabing low pressure, ano yun? 144, nangyayari yun dito. At yung isa pa, high pressure, nangyayari yun dito sa 1,400 kilopascal. Okay? Ngayon, sabi diyan, determine the, anong i-determine natin? Determine what? Determine the quality of ammonia. Ano yung quality? Anong letter yung quality? Binanggit ko na kanina. I've said a while ago, what is the symbol for quality? No, so yan, no? So, ito yung compressor, no? So, the symbol for quality is what? Quality is X, di ba? Yun ang tinatawag na dryness fraction.
Factor.
Ayun, or factor fraction, no? So, pwedeng 95, 98, 99, no? Malapit na yan sa dryness. Saan yung dry? Saan yung dry? Ito, no? Itong kalahati na to ay saturated, ano to? Saturated vapor. Gas to gas, no? Kaya nga, gas to, no? So, ibig sabihin, Hg, nandiyan yung enthalpy ng G, or pressure ng vapor, pressure ng gas, temperature ng gas, no? Ito naman, F. Ano yung F?
Fluid.
Fluid, basa. So, nandiyan yung HF, di ba? Nandiyan yung pressure ng fluid at saturation point. Basta saturated yan, no? Saturated. Nasa table yan. Ngayon, quality of ammonia is X, no? Quality of ammonia is X. Halimbawa, kung kukunin mo, meron kang mga enthalpy, paano yan? H, di ba, equals HF, di ba?
HF.
Ano bang formula niyan?
Plus XHG.
Plus HFG. So kung gusto mo yung isa naman, yung HFG naman, kung gusto mong makuha, HG minus
HF.
HF, Di ba? Yan lang naman, di ba? Ganun lang. Pwede yan sa enthalpy, pwede sa entropy, pwede sa specific volume, no? Ba, specific volume, di ba? V of G. Pag sinabing FG, meron kang quality diyan. Ibig sabihin, mix, no? Pag sinabing mix, meron kang dryness fraction. May mixture ng fluid, may mixture ng gas. So ano to? Yung yung volume mo sa gas, i-minus mo yung volume ng fluid. So makakakuha ka ng Fg. Saan yun? Sa gitna, di ba? Sa may bandang gitna yon. Ganon din yung sa H. Halimbawa, kukuha ka ng enthalpy, may given ka ng enthalpy of fluid. Saan yung enthalpy of ng fluid? Ito yon, no? Sa may left, saturation point. May ano to? HF is plus X H H
HG.
H oh, yan. Ganyan, no? So yung HG mo, no, minus HF, yun ang HFG. So ayun, meron kang HFG, tapos meron kang HF kasi ay, saan na ba tayo? No? Meron kang HF dito, meron kang HG dito, so makakuha ka ng HFG. Yun ang dryness fraction. So makukuha mo yung X, di ba? So yun ang ano doon. Ngayon, ano pang kinukuha? Mass flow rate. Anong sinasabi nating mass flow rate dyan? Ano ba yung ano ng mass flow rate? Ano yung ano ng mass flow rate? Class, unit, kilogram per
Kilogram per second.
second or kilogram per hour. Tingnan nyo, no, kung hour or second. Nako-compute na ano naman yan, di ba? Na ko-convert. No? There is 3,600 seconds per 1 hour. No? So, madali lang yan. Ano pa? Volume flow rate at the compressor. Ito nga yung sinasabi ko, no? Volume flow rate at the compressor, makukuha nyo yung volume flow rate. May formula dyan, no? No, normally, ang formula is has to do with the mean effective pressure. Yeah? Mean effective pressure times volume, magkakaroon ka ng work net. Yeah? So, work is pressure times volume. Naniniwala ba kayo rito? Pressure times volume. Ano ba yung pressure? Newton per square meter. Ano yung volume? Meter cube.
Cubic
Right?
meter.
Oh, so cancel dan. Newton meter. Ano yung Newton meter? Joule.
Joule.
Okay? Ngayon, kung specific volume naman, ba, meter cube per kilogram or per second, halimbawa ang volume mo ay volume flow rate, okay lang kasi yung second, okay lang yan kasi Newton meter over second is joule per second. Ito ay watts. No? Watts, di ba? Yun din, pwede rin yun sa power or energy. Pwede mong gawing kilowatt, tapos pwede mong i-convert na ng tons of refrigeration because 3.516 or 3.52 watts is kilowatts is 1 ton of refrigeration. Maliwanag ba yun? Ngayon, ano pa to? LD. Determine daw yung LD. Ano yung LD? Bore and stroke, no? Stroke. L is length, meaning length ng stroke. Ano yung stroke? Yung haba ng piston rod. Ano yung D? Ano yung D class? Diameter. Diameter ng ano? Ng bore. Ano yung bore? Yun
Bore.
yung bilog. Bilog ng piston. So, di ba? Ito yung piston mo. May piston rod. Yeah? May shaft. So, ano yung length? Ito. Length yan. Ano yung diameter? Ito, yung bore. So, D, L. D, L. Ayun yun. D over L, L over D, pareho. Ibig sabihin, pareho lang ang bore, diameter, at pareho yung length ng connecting rod. Maliwanag ba? Ito, yan o. No? LD, L over D is 1. Ibig sabihin, L is 1 times D. Kung ano yung length ng stroke mo ng connecting rod, yun din ang diameter na sukat. So, pareho lang. If that is the case, determine the bore and stroke. Hanapin naman, may equation naman, di ba? Bore and stroke of the compressor at 600 RPM, binigay yung speed. So makikita niyo yan doon sa formula. May mga formula ng compressor, no? Sa work. Ito na nga yung binigay ko ng isa, di ba? At meron pang iba. Okay ba? Maliwanag ba? So, para makita yan, maki-screenshot na lang o ibibigay ko rin naman para matapos na tayo, ano ko to. Yan. Class, paki-screenshot muna para panigurado, paki-screenshot. Paki-screenshot tapos ibibigay ko rin to. Number 5, problem number 5, ang inyong first assignment sa standard vapor compression system. And then pupunta na tayo sa mga sa mga equipment, mabilisan na to, no? Marami tayong tatapusin, no? Marami tayong dapat matutuhan dito. Okay?